Hello and welcome back to Advent of Code 2023. Day 15. We're starting on time again, second day in a row. We've got 1 minute to go. Let me just grab my coffee then. Oh, music on. So, yesterday's problem was a good problem. I mean, it wasn't hard to code. There was a little trick to it, clever trick to it, to stop you from having to compute 1 billion iterations. Today's problem, we'll see. Is it going to involve 2D grids again? Because we've had quite a few 2D grids lately, haven't we? Why is the rendering here a bit... Alright. Lens library. The newly focused parabolic reflector dish is sending all of the collected light to a point on the side of yet another mountain, the largest mountain on Lava Island. As you approach the mountain, you find that the light is being collected by the wall of a large facility embedded in the mountainside. You find a door under a large sign that says Lava Production Facility, and next to a smaller sign that says Danger, personal protective equipment required beyond this point. As you step inside, you're immediately greeted by a somewhat panicked reindeer wearing goggles and a loose-fitting hard hat. Was this wiki link necessary? Okay, hard hat. Oh, we got trebuchet, return of the trebuchet. The reindeer leads you to a shelf of goggles and hard hats. You quickly find some that fit, and then further into the facility. At one point, you pass a button with a faint snout mark and the label Push for Help. No wonder you were loaded into that trebuchet so quickly. What? No wonder you were loaded into that trebuchet so quickly. I don't understand that reference. What does that mean? What's the snout mark? Okay, I don't understand that sentence. You pass through a final set of doors surrounded with even more warning signs and into what must be the room that collects all of the light from outside. As you admire the large assortment of lenses available to further focus the light, the reindeer brings you a book titled Initialization Manual. Hello, the book cheerfully begins, apparently unaware of the concerned reindeer reading over your shoulder. This procedure will let you bring the lava production facility online, all without burning or melting anything unintended. Before you begin, please be prepared to use the holiday ASCII string helper algorithm, Appendix 1A. You turn to Appendix 1A. The reindeer leans closer with interest. The hash algorithm is a way to turn any string of characters into a single number in the range of 0 to 255. To run the hash algorithm on a string, start with the current value of 0. Then for each character in the string, starting from the beginning, determine the ASCII code. Alright. Increase the current value by the ASCII code you just determined. Set the current value to itself multiplied by 7. Set the current value to the remainder dividing itself by 256. After following these steps for each character in the string in order, the current value is the output of the hash algorithm. Alright, I get it. So the result of running the hash algorithm is 52. Ignore new line characters. So you comma separate, oh my god, okay. separate it by commas, find the sum of the hashes. Okay, I get it. I can do this pretty quickly. Alright, so... Okay. So, we want... for S in, so we want line.strip.split, comma, so that's going to give us each string, and treat find, let's just call it S hash, I can't think of a name. So what is it? It's, I think it's just return. So it's going to be sum of, so you take the car, the character, and what are the steps? You determine the ASCII code, which in Python is ord. All right. Oh no, it's not quite like this. Okay, so current equals 0 for car in S. We want current plus equal, so ord of car, then current equals, so it's going to be car times 17 percent, what was it, 256, whoops, current, like that, return current. Yeah, you have to do it like that because you need to multiply by 17 and do that. So we want total plus equal S hash of S. Is that it? 514281. I could have missed something here. Correct. All right, part 2. You convince the reindeer to bring you the page. The page confirms that your hash algorithm is working. The book goes on to describe a series of 256 boxes numbered 0 through 255. The boxes are arranged in a line starting from the point where light enters the facility. The boxes have holes that allow light to pass from one box to the next all the way down the line. Okay. Inside each box there are several lens slots that will keep a lens correctly positioned to focus light passing through the box. The side of each box has a panel that opens to allow you to insert or remove lenses as necessary. Along the wall running parallel to the boxes is a large library containing lenses organized by focal length, ranging from 1 to 9. The reindeer also brings you a small handheld label printer. Okay. The book goes on to explain how to perform each step in the initialization sequence, a process it calls the Holiday ASCII String Helper Manual, hash map for short. Each step begins with a sequence of letters that indicate the label of the lens on which the step operates. The result of running the hash algorithm on the label indicates the correct box for that step. I'm not taking this in well. Okay, the label... Need to see an example. Alright, let me just read this and then look at the example will help. Alright, so each step begins with a sequence of letters that indicate the label of the lens on which the step operates. So for example, this is CM, this is QP, okay. The result of running the hash algorithm on the label indicates the correct box for that step, okay. So we want to run the hash on the label, not the whole string for this. Okay. Then we get either an equals or dash. Technically hyphen. Dash is a longer character, although dash is kind of not in use anymore on most modern computers, I think. If it's a dash, go to the relevant box and remove the lens with the given label if it is present in the box. Then move any remaining lenses as far forward in the box as they can go without changing their order, filling any space made by removing the indicated lens. So we keep things in the order, but we take out of order. Alright, if it's equals, it'll be followed by a number indicating the focal length of the lens. That needs to go into the relevant box. There is already a lens in the box with the same label. Replace the old lens with a new lens. Remove the old lens and put the new lens in its place, not moving any other lenses in the box. If there is not already a lens in the box with the same label, add the lens to the box immediately behind any lenses already in the box. Wait, what? Hang on, what? Oh, with the same label. So the lenses have labels, okay. So there may be lenses in the box, right? If that label is not present. I think what we kind of want is a sorted dictionary, but Python doesn't. Python does have that somewhere. Replace the old lens with a new lens. So if we have the same label, label of the lens. So okay. Alright, I sort of get it. So if something has the same label, replace that with a new lens, so it may change the focal length. If there is not already a lens in the box with the same label, add the lens to the box immediately behind any lenses already in the box. Don't move any of the other lenses when you do this. If there aren't any lenses in the box, the new lens goes all the way to the front of the box. Okay. What does behind and front really mean though? Okay, fine, whatever. Alright, so after Rn equals 1, box 0. How do we get box 0 again? The relevant box is you perform hash on the label, right? Yeah, there we go. Alright, so Rn equals 1. Hash of Rn is 0, I'm guessing. So you go to box 0, and you put a lens with label Rn and focal length 1. CM hyphen. So CM, I guess, maps to box 0? Does it? No, wait, CM dash remove the lens if it is present, okay. Interesting. All right. Yeah, I think I get it. So we want to keep things in an order, but we also want to be able to look up whether something is present. So depending on the input size. All right, anyway, after doing all that, to confirm that all the lenses are installed correctly, add the focusing power of all the lenses. The focusing power of a single lens is a result of multiplying together 1 plus the box number of the lens in question. The slot number of the lens within the box, 1 for the first, 2 for the second, and so on. What does first and second mean though? Because back, behind, and front, so front means first. And when you put new ones in, they go second and third. Okay, fine. So it's just like a list, append to the end, right? Focal length of the lens. Alright, well, fine. I don't see anything algorithmically hard here. How many strings are we dealing with? I think we can get away with not using an ordered dictionary. I think we can just use lists, maybe. It's a bit... well... let's see. Okay. I roughly know what to do, but we got to do this step by step because there's a lot here. So, total 1. Okay, so that's part 1. Okay, so For part 2, we just want to, so during this process, we want to put the lenses in their places. Okay, so we need boxes. Let's sort this out. So boxes equals, so it's going to be essentially an empty list for 6. Empty list. All right. Part 2. All right. So we've got our string. All right. So how do we? Excuse me. Just do if equals in S. So in this case, we're doing the Alright, we'll do this in order that they've given it. So start with the dash. Alright, so if dash in S, so in that case, it's just going to be the first bunch of characters. So label equals S, ignoring the last character. Box equals, so it's going to be S hash. Let's rename this. Should we say box hash? Well, in part 1, there's no notion of box. What did they? It's just a hash. Why did they call it a hash? Hash is already a reserved term. Right, whatever, we'll call it box hash. Box equals box hash S. Just don't need to compute the hash multiple times. Let's just use that. All right, so got the box. So with hyphen, we are going to remove the lens with the given label if it is present in the box. How are we going to insert these lenses? Is it going to be a pair with label focal length? Because in that case, all right. So for LF in for I in range length boxes. All right, just have a look at all the box boxes. No. What am I trying to do here? No. Boxes, box. So this is one box. Also, let's call this box num. It's not actually the box. The box is the list. So box equals boxes box num. Alright, so for I in range length box, if box, so this is going to be a pair, label focal length. So the first parameter, let's say, is the label. And if that's equal to our label, then we want to do delete box, just delete that item altogether. Break. So there should always be one or none of those. Okay. Okay, otherwise we're dealing with the equals. So label, and then the focal equals s dot split on the equals symbol. Focal equals int, make it an int. So well, this is known here, so okay, so if it's equals sign, it needs to go into the box. So first we check if there's already a lens in the box with that label. So similar to this script here. Now this is the slow bit. I'm hoping that it's not too slow because it's linear time. And deleting an item is also linear time because the whole list needs to be shifted in memory, contiguous memory. So hopefully this isn't too bad. I in range length box. If box I equals label, then we need to change box I. Box I equals label focal. From whatever it was before to this. Break. Else, so if we didn't find it, then box.append label focal. Let's try running that. If it actually completes on time. Oh, it does. Interesting. So it's quite fast. So then let's just have a look at boxes. That looks good. Okay. So we want to for box in boxes for I lens in enumerate. Hang on. What numbers do we need here? We need the box number. So I box in enumerate boxes for J lens in enumerate box. So we've got those two numbers. it's going to be total 2 plus equals. So it's going to be the first number is going to be the box number plus 1. So I plus 1 times, I don't know if this will take precedence. Let's just bracket that. The second number will be the slot number of the lens. It's 1 indexed, so it's going to be J plus 1. And then the third number is the focal length, so it's going to be lens, the second parameter. Is that it? And then I don't see anything challenging here. Could be wrong though. Could always be wrong. Nope. It's wrong. Let's see. If there is not already a lens in the box with the same label. Hello, DIJ. And the lens immediately behind. Alright, let's try the example then. How goes day 15? Doesn't look hard. I think I've pretty much written the approach now. I just need to find out what's gone wrong. I'm not getting the right answer. But the runtime is quick. So where is the example input? This is the example input. See, if you want algorithmic efficiency, you would use an ordered dictionary. That makes all operations kind of roughly constant. All right, let's go back to. But it seems the input's small enough, so we can get away with this. So 5139 is our number, and what it should be is 145. What the fuck? Okay, that's way off. Way off. Okay, let's start by printing the boxes. I want to see what we end up with. What the... So we're saying there's nothing in these boxes. No, something's wrong here. Box 0 and box 3 should have... We should have stuff in box 0 and box 3. But for some reason we are going way... Oh! Okay, we shouldn't be hashing S. Okay, so... Okay, you know what? I think I will rename this method. Box hash is misleading because it's just a hash. Let's call it just S hash then, as it was before. Okay, so here it's gonna be boxes S hash label. Okay, and then down here it's different. The label, because we split it differently, so we can just compute box differently. Here it's going to be label, but label is obtained by a different process. Does that make it right? 145? Correct. And now for the big one, 244199. Correct. All right, that was a nice easy problem. How long did that take me? About 35 minutes. All right, there wasn't anything. You see, I thought the catch was going to be that all this. So I was using lists, Python lists, for storing these lenses. That's really inefficient because every time you insert into a list, I mean, if you insert to the right-hand side of a list, that's fine. If you insert anywhere else, you consume linear time because then Python has to go and shift everything in memory because it's using contiguous memory in the computer to store that list. So if you take something out from the middle, it moves everything up by one. So it uses linear time every time, which is horribly inefficient for any piece of software. And you don't want to do that. But in this case, it's surprisingly fine. I thought that was going to be the catch, and you needed to use an ordered dictionary, which I think Python has a library for. Or maybe not. Maybe you need to import. No, yeah, collections, OrderedDict. Yeah, so the efficient way of doing this would be to use an ordered dictionary. Should we try doing that since I finished early? Alright, before I do that, let's just have a look at the old stats and stuff. So stats, yeah. We've just started. The problem launched half an hour ago, so we're in the top 3,000. Yay! My leaderboard. Yep. 2 of us. Umaro is catching up. And Captain Coder's leaderboard. Oh, I'm actually first. I was the first one to complete it today. Interesting. All right. Out of these people. All right. So. Oh, and the leaderboard for this day. 1 minute 26 for both stars. Bloody hell. That's pretty impressive because this is not a very... I mean, I could sort of see how you could write it quickly, but it's not exactly a very textbooky, so you've got to write some original code here. You can't just copy in a library that you've got from before. Okay, cool. What was the 11 minutes? So I was like 20 minutes off. Okay, let's see if we can do it using an ordered dictionary. Just I wanna try and do this. So OrderedDict. So so you can pop an item. We're not going to be doing that. Move to end. Oh, these are just new methods. Okay, what other stuff does it have? So it stores them in order the keys were last added, that's fine. And the value can be updated. So I assume if you update the value, it's not exactly going to change its order, because we want its value to be altered without changing its order. Should we just try using it and see then? So we want from collections import. How is it? Capital letter? OrderedDict? Yeah. Oh, gotta open the IDE. So we want OrderedDict for each box. All right, so for this one, label box. Okay. So we, instead of doing this, we want to say if label in box dot can we just delete? Are we allowed to delete? Pop item. So you could move to end and then pop. I'm guessing pop item does both of those things. You need to provide a key value pair, but I don't care about the value. We just want the key. Is that allowed? Wait. Bool. Pairs are returned in, so what we want. We don't want stack, we want a queue, right? LIFO. Does it matter? Shouldn't this be specified? Okay, fine, LIFO. What do I say then? We want true. What do we want now? Just pop the label. What do you want? Pop item. What are the parameters? Damn it. Why does it just show dot dot dot? Show me the parameters here, please. Oh. Okay. Oh, it opens up the browser. No, don't do that. Okay. Let's have a look at the... Alright, I'm just going to look at the website then. Pop item, move to end. Why is this so complicated? I just want to know what the parameters are for... Okay, okay, here we go. Key... No, that's... Alright, where am I writing this? Pop item... I don't understand. Is it not want? It says remove and return a key value pair from the dictionary. I assume it... Oh, okay, I get it. It's just pop. I thought when it says return a key value pair, I thought it means we need to specify the key value. No, you just say pop item and it returns the last one. Right, that's not what we want. What do we want? Box dot clear? What's clear? That's gonna clear everything, isn't it? No. Box dot... Okay, I think... we can do move to end. Let's try this. Move to end. So key equals label. And last is true by default. Okay. And then box dot pop, right? Oh, pop takes a key value. Okay, 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 okay. That's what we want. Move to end and pop item together make pop. Right, that was more complicated than necessary. So just comment that out. So, all right. So if label inbox, we remove it. Okay. Okay. And then the other one is label focal, box focal. Okay, so we've got the things we need. And now, don't do this. We want, so we want if label inbox, box dot update. Well, how do we use update? Supports keys and get item. Or do we just say box label equals but will that, I think that will, no, hang on. We want box update to make sure it doesn't change the order. We want to update it in place. So box yeah, it should be update, but I don't know how to use update. Label Hello, Hereford Bull. Am I in Europe? No. I'm in Thailand. So it's midday for me. Just, well, almost 1 p.m. And I've already finished the problem, but I'm trying to rewrite it using OrderedDict. I'm just confused about how to use this method. Okay, so I guess if I just do label, it's almost midnight here. Yeah, so Eric, the guy who makes this website, in his time zone, he likes to launch it at midnight because he's able to be at his computer at midnight and check that everything's working. We've been watching, big fan of your Advent of Code videos. Oh, nice. So you found me through YouTube. Yeah, today's one is a shortish one. I've completed it in about 30 minutes, so now I'm just trying to he's somewhere on the East Coast, the AOC runner person. Who? Oh, hang on. I'm still looking at the ID back. If I just go label focal, that. Mutable mapping. I don't understand this documentation. What is it saying? Supports keys and get item. Iterable. Iterable tuple. Can I just say key equals label value equals focal? Can I do that? Hopefully that does what I want it to do. Alright, so else. So if it's in the box, we update it. Otherwise, box dot. I think we can literally just do this now. Box label equals focal. So now that should efficiently be updating the boxes. All right, just hide that. OrderedDict. All right, now if we so for J box dot items. So again, we go with I plus 1, J plus 1, but then here it's going to be lens 1 as before. Will that just work? Int and string plus equal int and string. So lens 1 is a string. All right. I just want to print what these lens look like. Lens is a string int pair. What is this? I see. Key equals what? Okay, I do not know how to... Can I not just do this? No. Will it actually... 244199? Wait, no, that's right, isn't it? Hang on, let me close all these browsers first. Go back to the problem. 244199 is correct. All right, so this works, but we can simplify this. So look, I've done if do this, do that, else do this. So basically this simplifies to just that. And the reason this works is because I guess ordered dictionary is designed so that if it's in there, it will update. So if label's already in there, it will update, but it won't change the order. If it isn't in there, it will just insert. And it just does what we want it to do out of the box. Great. So that's also actually efficient. So I would say that's the proper way of doing this, because ordered dictionary does all these operations in constant time, well, expected constant time. So if you were to use a list, as I was doing before, it would be linear time to shift all the stuff in memory. It's pretty inefficient. OrderedDict is just does it. Nice. And two four four one nine nine. Nice. Let's just take out these print statements and then my code is production ready. 514281 244199. Are those two correct? 5. Yep, 514289. Okay, good. That is a really nice compact program now. No need to well, just piggyback off the built-in methods of OrderedDict. I'm glad I don't need to use update because I didn't understand how to use update, but yeah, it's built into this, so it knows, it's smart. I have another, I just want to try one more thing. Can I not just, can I do delete box label like this? Yeah, you can. You don't need to use the pop method, you can use what you normally use for dictionaries. Or maybe pop is actually... No, I'll use pop. That's actually looks better. Alright. That's it then. Let's see. I'll take a quick look on Twitch, see if it's a bit early. I don't think, well, certainly Captain Coder wouldn't be coding. Anyone else? Bad Cop, I don't think he'd be coding either, yet. Alright, let's just, oh, Zombie Chow is doing this problem.
Okay, so what is it? It's end, so b.end.previous.
There's also Alcar.
Just killed my vibe, you know.
All right. But anyway, I don't particularly want to raid anyone today. Maybe tomorrow. All right. Thanks for watching. I'll see you tomorrow for day 16. Bye bye.